A good starting point for us is to understand how structural equation modeling differ from other statistical modeling. Structural equation modeling is a statistical way of modeling because it is dealing with numbers, so we have to convert any, if we are using, for example, content analysis, we have to use the textual information and convert them into numbers. Content analysis is a technique where we can convert text, pictures, any such information into numerical form, either using the sign vehicle language, using keywords, for example, or using the semantic, using the meaning as a basis. So there as the basis, we can convert into numerical form. So structural equation modeling is in that sense, is a statistical technique. But the difference between structural equation modeling and other statistical modeling is that one of the key advantages in structural equation modeling is that it can test whether a theory fits into the data. Now, what we do in other techniques is we collect data, observational data, and then we say, okay, here's our data set, and then we for statistics, then we test it out and see whether that the theory, it conforms with the theory, or because we come up with a hypothesis saying that our null hypothesis is that the current status is the same, and alternative hypothesis is we are undertaking this research suspecting that there's a different situation that exists that the theory is not explaining, or the logical body of reasoning doesn't explain. But in structural equation modeling, our starting point is actually the theory, and you can say, yeah, even in other techniques, yeah, we're using the theory to build the hypothesis. Yeah, true, but it is our data in other techniques drive testing the theory. But here, it's actually other way around. We start with the theory, and then we build a model based on the theory, and then we get a set of data and see whether this set of data actually conforms with the theory. So our starting point in structural equation modeling is the theory. So it is based on the theory that we build a model. Now, what we mean by building a model here, theory is a way of explaining something, right? And when we explain it, we are explaining some relationship, right? It's a relation. It's something about some relationships. And when we talk about the relationships, there's underlying meaning in this relationship. I mean, we can manifest, we can talk about those relationships in different ways, but those different ways are the manifestations. But really, within that is that underlying meaning. Those underlying meanings are built upon what we call the constructs. So in theory, it's about the constructs speaking to each other. It's the hidden thing, right? And the observations that we see, the manifestations or the behavioral manifestations are driven by this. Right? But really, what's underpinning is that the construct. So what we do in structural equation modeling is test the data used in the theory. So first we start, and the theory has these concepts and various conceptual relationships, whereas in data we are trying to look at the variables and then look at the observations and then measure the observations. So the difference here is that the other statistical techniques are driven by the data, because our focus there is about the observations, and we measure the observations. Those measurements of observations become our data, right? Facts. Right. And then we use those facts to test the theory. That's what we do in other statistical techniques. But when it comes to structural equation modeling, we start with the concepts. We say, okay, here's a theory. In this theory are these constructs, right? The hidden meaning in that. And based on this hidden meaning, I'm going to build a framework, I'm going to build a model. And I'm going to, once I have built this model, then I will go out and collect data and see whether this set of data fits into this model. So that's what we do in structural equation model. Right? So this model building in structural equation modeling is about the relationship among constructs in the theory.